Okay, ladies and gentlemen, today we are continuing with our topic of solving by substitution, but today we're going to take a special look at the special solutions. And as you might remember, that's no solution and infinite solutions. So we're going to take a look at what that might look like when we're solving using substitution. So let's go ahead and take a look. All right, so to get us warmed up here, I want to go back to the option of graphing to find a solution and what those special solutions look like, just to refresh those brains of yours. So this first graph here, what is that one going to be? If you said no solution, you were on the right track, my friends. How about the second one? You said one solution, you are dead on. There's going to be an x comma y, and in this case it's 2 comma 4. And the third one, if you remember, there's a red line hiding right underneath that one, so it's touching everywhere. Infinite solutions. So what we want to think about today is how might we know these solutions exist when we solve using substitution? What might our answers look like? Well, let's go ahead and dig in and discover. So I've got two substitution system of equations here. One of them is going to give us no solution, and one of them is going to give us infinitely many solutions. And I want you to kind of see if you can figure out for yourselves which is going to be which. So let's just dig in and solve by substitution. So in this first one over here, in order to start substituting, we're going to need to get a variable alone. And you notice that this second equation is going to be easier to get a variable alone. So let's go ahead and subtract y from both sides. And that'll give us the x alone equal to -2 minus y. So in the first equation, I'm going to plug this in instead of x. So the equation that I'm solving is 2, -2 minus y plus 2y equals 8. All right? So we keep solving here. We need to distribute first. That'll give us -4 minus 2y plus 2y equals 8. We can combine like terms. We get -4 equals 8. Huh. What do you think that means? I'm not going to tell you just yet. Let's try solving the other one and see what we get. We know it's either going to mean infinite or no solution, so there's no super suspense there. But I want you to make this differentiation for yourself. All right, let's try solving this second one here. This one's a little bit more complicated in substitution. Now, as I'm looking at these, I think I'll just start with the first one, just because it's the first one. Now, do I want to get the x alone, or do I want to get the y alone? I think I want to get the x alone because I know it's going to be divisible here, and that might make my life easier. So let's take a look then. We've got 3x minus 2y equals 3. So I'm going to add 2y to both sides. That gives me 3x equals 3 plus 2y. And then I divide everything by 3. And that gives me x equals 1 plus 2/3 y. Okay, so I figured out what x is. So that means I'm going to plug in this instead of x. So that means I have -6 parentheses 1 plus 2/3 y parentheses plus 4y equals -6. Whew, that's a boozy. All right, let's distribute. That'll give me -6 plus Doing this without a calculator, 6 times 2 is 12, divided by 3 is 4. So it gives me negative 4y plus 4y equals negative 6. Okay, combine like terms. Ooh, negative 6 equals negative 6. All right, so which is which? What do you guys think? Which one is no solution and which one is infinite solution? Drum roll, please. No solution, because they are not equal. Infinite solution, because they are equal. That makes sense, right? Now, what you noticed in these is once you substituted and started solving for that first variable, the variables disappeared. So when the variables disappear is when you will end up with these special solutions. Okay? When the variables disappear, you get no solution or you get infinite solutions. Hopefully that makes a lot of sense to you guys. All right, now I know how much you all love word problems, so I figured we'd squeeze one in here. Let's write and solve a system of equations word problem. Okay, so we've got a Nature Center charges $35.25 for a yearly membership and $6.25 for a single admission. That means you get to go in one time. So you guys know, like PriceSmart. Here in Barranquilla, PriceSmart charges, I don't know, like 90,000 pesos a year, I think. But what if they charged a one-time fee? Maybe for some people that would be cheaper. All right, so last week it sold a combined of 50 yearly memberships and single admissions for $660.50. How many memberships and how many single memberships were sold? All right, so the first thing you want to start with here, guys, is defining a variable. And in this case, we have two variables. We have, looking at the question here, it says how many memberships and how many single admissions were sold. So we're going to start by defining our variables. We're going to let X equal membership and Y, oops, that's not a D, and Y equal single entry. Now, what gets tricky here for a lot of people is deciding which pieces of information go with what. So what I want you to look at is two of these pieces are totals. We've got 50 total yearly and single memberships. That has nothing to do with the cost, simply the total. They sold 50 of them. 50 X's and 50 Y's total. Now the other one, that 660.50, has to do with the amount that each one cost. Now, memberships are $35.25. So $35.25 per, so multiply by the total number of memberships. Plus, the singles are $6.25. So $6.25 times the number of single entries. Now, this is the system of equations that we're going to try to solve. Now, unfortunately, I'm running out of space on this itty-bitty little screen. Bah humbug. Alright, so let's see if we can give this a try. I think I might have to pause this and erase a little bit. Give me a second here, kiddos. Alright, I went tiny. Hopefully you guys can still read that okay. Alright, so we're going to do substitution to solve this. So we're going to use this first equation, and we want to get it so that you have one thing alone. I know you guys like the y as alone, so let's get the y alone. That means we've got to subtract x from both sides. So that means we're left with y equals 50 minus x. So that means that 50 minus x is going in instead of y. Alright, so let's start our substitution here. We've got 6 60, 50 equals 35.25x plus 625 parentheses 50 minus x. So you notice all the y's are gone. We're solving for x here. We've got some distributing to do right off the bat. So that'll give us 660, 50 equals 3525x plus 312, 50 minus 625x. We got some like terms to combine. That gives us 660, 50 equals 3525 minus 625 is 29x. Finally, things are looking a little simpler. All right, let's move that over to the other side. That gives us 348 equals 29x. Dividing both sides by 29. And we get that x equals 12. Does that seem reasonable? Well, remember we have a total of 50 memberships, yearly and single. So 12 of them being memberships, sure, that's reasonable. So those are the yearly memberships. How can we find out how many single admissions? Well, we just got to go back and solve for y. So we can use 50 equals x plus y. And instead of x, we plug in the 12. And then we'll just have to subtract 12 from both sides. And so then that gives us 38 equals y. So that's how many single entries they sold. So final answer needs to be word form, not ordered pair form. So the store sold 12 yearly memberships and 38 single entries. Easy. Not too bad, I bet. All right, guys. Homework tonight then, you've got 3 problems using substitution, numbers 15, 16, and 17. And then number 7, you'll need to use substitution to solve. So you can guess that probably 15, 16, and 17 are going to give you some special solutions, and number 7, you need to do your best to try to write the equations and solve using substitution.